Rational numbers is the topic of our Day 7 Innovative Classroom activity. This lesson will continue the beginning of our study about rational numbers that we did in Day 6. That lesson can be found in a two-part previous YouTube video. Just to review some of the standards, you can pause the video at this point and read these if you wish. We will be hitting this one and this one pretty strongly in this video, but with this one, 6.ns, 6.c, we're pretty much going to just find and position integers and other rational numbers on number lines. We won't be doing much with coordinate planes. This is something that we addressed in our last lesson. Okay, our I can statements are: I can interpret statements of inequality as statements about the relative position of two numbers on a number line diagram. And I can write, interpret, and explain statements in order for rational numbers in real-world context. Now, just to review a definition for rational numbers, you should always think ratio when you think of rational numbers. A rational number is any number that can be written as a fraction. Technical definition of a rational number is, well, a rational number is any number that can be expressed as A over B. A is a numerator, fraction bar, B is a denominator, where A and B are integers and B is not equal to 0. Rational numbers include integers, fractions, repeating decimals, and terminating decimals. Now, in the activity that we're going to be working on today, we're going to focus primarily on integers and fractions. Rational numbers can be positive or negative, and we'll be working quite a bit with both of those, especially in terms of ordering integers or fractions. Now, here we have a number line, and you can compare rational numbers using the number line as you move from left to right on a horizontal line. And here we have a horizontal line, and this would be left, of course, and this would be right. And as we go from left to right, our value increases. Now, on a vertical number line, one that would be like a y-axis if this were a coordinate plane, as we go from bottom towards the top, we increase in value. Remember in our lesson 6, day 6, we talked about how at zero, think of it as sea level, and below that would be increments below sea level, which would be like negative numbers, and above that would be height above sea level, like altitude, and this would be our positives. Now, you can use a symbol greater than, less than, or equal to compare rational numbers. Now, I'm going to write a few fractions up here and numbers and see how we can do with ordering these. Now, let's imagine that this point here, we'll say this point here will be 0 on our number line. And I'm going to go 1, 2, so I'm going to skip 2 to put integers on this number line. Now, integers can be positive or negative. Now, when I'm skipping 2, what do you think is going to be in this middle, in these middle notches, places where there's not a whole number? Think about it for a second, then I'll tell you. Well, these would represent halves. This would be 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and 5. And the reverse would be this way, the opposites here. Now, this would be -1/2, -1, -1.5, and so on. Now, like we said earlier, when you go from left to right, you increase in value. On this number line, -5 is the least value of any of our numbers. -5 is less than -4. -4 is less than -3. -2 is less than +2. -1 is less than 5. So as we go from left to right, we increase in value. So as it is, our numbers here, our integers, our rational numbers here, are written in order from least to greatest. Now, you can compare rational numbers, like we said earlier, by using a number line. Now, let's say that I had to figure out which was greater, 2 1/2, or negative 2 1/2, I'm sorry, negative 2 1/2, or negative 1. Well, here's 2, negative 2, and here would be negative 2 1/2. So right here would be negative 2 1/2 on our number line, and right here would be negative 1 on our number line. Because negative 2 1/2 is to the left of negative 1, we know that negative 2 1/2 is less than negative 1. All right, we'll do a couple more of these, and let's see how good you are. Okay, well here I have changed up our number line. We have 0 here, and then we have a blank, and we have 10, blank, 20, blank, 30, and so on up to 50. Here we have a blank, negative 10, blank, negative 20, and so on. Think for a second, what would go in those not negative, but those empty spaces that we have not identified? Good. Hopefully you thought 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and so on. Negative 5, negative 10, negative 15, negative 20, negative 25, and so on. Now, here I have 4 integers, 4 rational numbers. I have 12, negative 13, negative 35, and 25. Why don't you use this number line to help you figure out what order our numbers can go in. I would plot them out on the number line, and then that will help you be able to write them from least to greatest. That will help you order them as well as compare them. Take a moment to do that. Pause at this time and see if you can figure it out. Okay, assuming that you went ahead and did that, I'm going to show you how you did. Let's look and see, how did you do? Well, we have positive 12 right here. Now, here we have 0. We said 5, 10, and 15. I would assume 12 would fall somewhere right around there. Negative 13, 0, 5, negative 10, I'm sorry, negative 5, negative 10, negative 15. That negative 13 is going to fall somewhere right around here. Negative 35, well, 0, negative 10, negative 20, negative 30, negative 35 right there, and positive 25. Well, there's 20, there's 30, so 25 would go right there. So if we were to then go ahead and plot these out, and I'll do that right now, we said that at this point here we had negative 35. At this point here we had negative 13. At this point here we had 12, and at this point here we had 25. Now, negative 35 is our lowest value number. Negative 13 is greater than negative 35. 12 is greater than negative 13, and 25 is greater than 12. So using a number line is one way that you can figure out how to order integers or rational numbers, and it will help you compare them. Now, we have another thing that we can do. We could also look at numbers or fractions, and we can compare them just by using our knowledge of which is greater and which is least. Let's look at this for example. Let's say I have 1/8 and I have 7/8. Well, they're both positive numbers, so I don't have to worry about is one negative and how that plays around with it, but they're both positive and they both have the denominator of 8. I know that 1 is less than 7, so I can say 1/8 then is less than 7/8. Let's say I do have a negative fraction here, 3/8, and then I have 5/8. Well, we have both the same denominators again, so that's pretty good. That's easy, makes it easier for us. We have negative 3 and positive 5. Well, we know negative anything will be less than positive 5, so we can say negative 3/8 is less than positive 5/8. Let's change it around. Let's say we have positive 3/8 and negative 5/8 this time. once again, we have the same denominator, so that doesn't affect anything. And here we have -5 and +3. Well, any negative number will be less than a positive number. So even though the absolute value of this may be greater than the absolute value of this one, in reality, if you have -5, that's going to be less than +3. Now, one of the things I would like to talk about to help order things, to kind of maybe in your mind keep everything straight, imagine if you were a thermometer. Let's look at this as a thermometer. And let's say that at this point here we have 0 degrees Celsius. So let's say we have at this point 0 degrees Celsius. Let's say that it got very, very cold. And as it got very, very cold, the temperature dropped. And let's say that it was 5 degrees below 0 Celsius. And let's say up here we have +5, and here we have +10, and here we have +15, and I'll put -10 here and -15 here. Let's take this -5 degrees Celsius and compare it to -15 degrees Celsius. Well, I kind of made a mess of that. Let me fix that a little bit better. Now, because -15 degrees is lower than -5 degrees, we know -5 degrees is greater than, more value than -15 degrees Celsius. Just speaking in relative terms, I would rather the temperature be -5 degrees Celsius than -15 degrees Celsius, because this would be much, much colder. Let's look at another one. Let's say I have 15 degrees Celsius and I have -15 degrees Celsius. Because 15 is much higher on the vertical number line, it is going to be greater than -15 degrees Celsius. Just because we have the same numbers doesn't mean anything, because this is positive and this is negative. Therefore, these are opposites. Let's say I had 15 degrees Celsius on Monday, and then I had 15 degrees Celsius on Tuesday. We would say that these are equal. 15 degrees, 15 degrees, they're both positive, so they're going to be equal. So there you go. That's just an example of how in the real world you can see how to make comparisons. Now, there is another way that you can compare fractions if they don't have like denominators. Like, let's say you had 3/8 and you had to compare that with 2/4. Well, to make these like denominators, you can figure out what is the least common denominator of both numbers. And that would be 8. So 3/8 doesn't change, but 4 times 2 gives me 8. If I times this by 2, I must times this by 2. 2 times 2 gives me 4. And so in this case, I see that 3/8 is less than 4/8. Another way of doing this would be to use a calculator to help you. You can get a calculator out and you can divide your numerator by your denominator, and whichever decimal is greater, that will be the fraction that is greater. But as we've been working a whole lot on coming up with least common denominators, I would prefer my students, if having to do an assignment like this, that they would go ahead and try to find the least common denominator. Now, my students will be required to complete an activity like this, turning for a grade for their day 7. The directions here say for questions 1 through 6, refer to the number line and use less than, equal to, or greater than to compare the integers. Now, here is a number line that you can use. Notice that it has 0 here, then 5, 10, 15, and then 0 here, -5, -10, and so on. Now, that number line will help you out with items 1 through 6. There's not a number line for 7 through 12, but just keep in mind which number would be farthest left on the number line. With 13 and 14, just write the integers in order from least to greatest, and then just identify were these written in least to greatest or greatest to least. I hope this video helped. Thank you.